for the final project, we were given a set of data and we are to come up with a strategy to tackle this machine learning problem. So in order for me to do that, I decided to go through a few steps. And the very first step for me was to decide what type of problem that we are trying to resolve here. And again, this kind of aligns with the questions that were given to us for this final project. You'll notice that I'm just following essentially the same steps. But the very first thing is to decide what we are trying to tackle here with the data, what we are trying to get as an output. And it became quite obvious to me that we are trying to get a single prediction resulting in a regression type situation here. So that kind of narrowed it down to experimenting with different types of regression models. And the ones I ended up selecting was simple linear regression, SVR, or support vector regression, decision tree, and random forest regression models. Again, this is just me, and there are many other types of regression algorithms that you can essentially experiment with, but just to align with the project requirements, I decided I'm just going to limit it to these 4. Now, one other part that I learned through my exposure to machine learning problems and deploying machine learning algorithms was that it's better to pre-process the data if there are any processing that needs to be done here. So that's what I did. I went through a few steps to clean up the data, if I may. And the first thing I did is to look at some missing data, if there were any. I don't necessarily think there were any missing data here, but I don't mind running that step anyways, because if it's a large data set, I don't necessarily have the bandwidth to go through the whole file to figure out where there might be some missing data. So I did that part. And then I did the split. I used 80 by 20 rule, 80% training data and 20% for test data. I did some feature scaling. I noticed that the scales for each feature is unique. And in order for the machine learning model to better understand the data, it's better to have them in the same scale. So there are some mechanisms that we'll look into that allows for us to scale. And that's what I did. And a couple notes though, that I used all the different features because I'm not too familiar with this type of situation where we are trying to predict energy output based on certain parameters or features. So I decided I'm not going to leave out any of the features. I'm not going to do any dimensionality reduction. I'm just going to stick with the different columns that we were given. There are not too many anyways. And I also decided that I'm not going to do any hyperparameter optimization or fine-tuning. I'm just going to use the basic, just to keep it simple. Once we are able to train our models and deploy, then the next step, aligning with the project requirement, was to look at the performance. And the 2 measures that I used, the first one was the R-squared score, which was to measure the performance of the deployed models based on the test data. Now, in order for me to be able to compare one model against the other ones, I decided to use k-fold cross-validation, and that's what I chose to effectively get some measurements that will allow me to compare performances across models. So once I did some performance evaluation, it became quite easy for me to select the model as the final model of the ones that I decided to experiment with. It is not always the case that it's just as easy for us to select one model, and that is part of the reason the idea is for me to go through as many different models that I can and get a sense of which one probably is the best one for me to select. So that's my strategy. Now, just one other note, once I was able to capture these 2 here, the R-squared score and measurements given by the k-fold cross-validation, I created this chart that gives us a clear picture as to how they were comparing against each other. So the simple linear regression had a 0.93 R-squared score, which is pretty decent. And accuracy was 92.76% with a standard deviation of 0.63%. By the way, those accuracy and standard deviation measurements were given to us by running k-fold cross-validation. So that's how the simple linear regression accuracy or performance looked. Now, as compared to the next one, which was support vector regression, I was kind of surprised actually. Keeping everything the same, the performance was quite low with support vector regression 0.33, and for accuracy 30.03%, very low, and 0.73% standard deviation. Now I looked at decision tree regression next once I deployed, and I noticed that it's quite similar to what we got as performance for simple linear regression. So it's 0.93 R-squared score with a 92.39% accuracy and a standard deviation of 0.88%. What ended up being my selection ultimately was random forest regression, and the reason is quite obvious. It performed the best, both looking at the R-squared score measurement as well as the accuracy and standard deviation. 0.96, 95.41% for accuracy, and 0.49% standard deviation, which is the lowest of all the standard deviations that we have seen anyways. So again, random forest was the selection. Now, I just wanted to quickly show you the model, and that's the random forest regression model. I should mention that, you know, those other ones are here too. I'm not going to go through them for the sake of time, but essentially following the same standard template, I was able to run each and every single one of the models. So importing the libraries, importing the data set that was given to us, looking at the data a bit, taking care of any missing data. Again, I believe that I didn't see any, but I thought I'll just run that step anyways. Splitting the data set into training and test. Just as I mentioned before, is 20% test and 80% for training. I did some feature scaling. I used a standard scaler for this, but there may be other options here too, and you can always tweak the parameters if you don't necessarily like to see the data the way I'm looking at it. I just didn't see it as being an issue, so I left it at that. Then I used random forest. I called it up and I fitted my training data into my model, and once I was able to do that, I predicted and I captured the data and then I printed them next to each other. So the predicted y values versus the test values, so we can get some sort of an idea how in real world are they performing, the predicted results versus the test results. So if we look at it briefly, you'll notice that majority of the data are within the range, and of course there are some exceptions. I noticed that there was one 432.9 for predicted value versus 440.29. So I thought that was not within the range, or not what I expected. But then again, with machine learning models, as we know from the class, the instructor was quite clear as well that, you know, it's not 100% science, exact science. So this is the part where I actually go through the evaluation phase. So first I evaluate with the R-squared score, and I got a 96.96, I think. And then I evaluated the model performance using k-fold cross-validation, returned a 95.41% with a standard deviation of 0.49%, just as we saw before. So that's how I ended up selecting this random forest regression model. Thank you.